Before we discuss about TP5 question 1, there is something you need to know about modulus function. Not sure whether it's been taught clearly in O-level. Now, in O-level, you may have come across modulus function, whereby this is like the definition of modulus function. So, what is exactly modulus of x? It is made out of two separate equations: x, the so-called the positive version, and negative x, which is the negative version. So when does the modulus take on the positive version? When the value inside the modulus is greater or equals to 0, it takes on the negative version when the value inside is less than 0. Then what about in graphical sense? You see, this is roughly the shape of a modulus x graph, a V shape. Actually, it's made out of two separate line segments. This line segment with a positive slope, this is the graph for y equals to x, and from what we written here, it's only when x is greater or equal to 0. Whereas the negative slope segment is actually y equals to negative x. And this one is only true when x is less than 0, as explained by here. So let us see a more general modulus equation. Maybe let's say x minus 1. What is modulus of x minus 1? Similar idea. It takes on the positive version when x minus 1 is greater or equal to 0. The value inside is positive. That's why the equation is the positive version. And it takes on the negative version when the value inside is less than 0. Now, I don't want inequality in x minus 1. I just want inequality in terms of x. So I can rewrite this as x minus 1 when x is greater or equal to 1. And it takes on the negative version when x is less than 1. Now, so when we draw the modulus, the graph of modulus x minus 1, it looks like a V shape, again, with 1. Similarly, this positive line segment represents the positive version. You can see this line segment, the positive version, is true when x is greater or equals to 1. Whereas this line segment, is the negative version when x is less than 1. Now, with this information about modulus function and its graph in mind, let us proceed to solve topical practice question 1. And we are required to solve this inequality, bearing in mind that a is greater than 0. Now, whenever you see modulus graph or graph with very funny equations, my recommendation is to use the graphical approach. So how do we use graphical approach? This is my graph number 1, and this is my graph number 2. And I want to see what region of the x-axis whereby graph number 1 is below graph number 2. Less than means the whole graph is actually below the other one. So let us just draw the graph. First, let us draw graph number 1, x plus 3a. So if you work it out, it should look something like this. Whereby this is 3a. Sorry, it should be negative 3a and 3a. So for this modulus graph, as like what we saw in the previous two examples, again, there's this V shape, and this graph is actually made of two separate line segments. The positive slope line segment is actually y equals to x plus 3a. When x is greater or equals to negative 3a. Whereas this line segment, the equation is actually minus x minus 3a, the negative version, and it only takes this form when x is less than negative 3a. Now let's take a look at the second equation, a minus 2x, whereby I have a negative x coefficient, so it should be a negative slope graph. So let me use another color. The graph should look approximately something like this. Okay, sorry for my not very straight graph. X-intercept as a over 2, you can go and solve it yourself. And y-intercept should be a. Now you may wonder, why do I need to know, details about this modulus graph? This line segment is x plus 3a, the other line segment is x minus 3a. Now it's because we need to, when we want to solve inequality, we need to find out what exactly is this point of intersection. And in this case, you can't really use GC because we have this unknown a. Bear in mind that a is positive, that's why negative 3a should be the negative value. Now, how do we solve this unknown? Point of intersection, I call it B. So let me work it out over here at the bottom left corner. Now, this point of intersection is actually arises from this line segment and the blue line. So to solve for B, I'm taking the intersection between this blue line and this positive slope line segment. So it will be a minus 2x equals x plus 3a. So this means I have negative 2a equals to 3x. So x is equals to negative 2/3a. And this is precisely my B. So from here, you can see that we want to find the region whereby the modulus graph is below, the blue graph. So I want the region whereby the black graph is below the blue graph. So you can see that the region I want is actually x less than minus 2/3a. Take note, I want strictly below. So it should be this region. Let me highlight it. So it is this region and excluding b. So my answer would be x strictly less than minus 2/3a. So for the first part, we want to solve this inequality model x plus 3a strictly less than a minus 2x, and our answer is x less than negative 2/3a. So the question says hence, that means you need to use the answer for the first part to solve for this inequality to the second part. And most of the time, you will involve some kind of substitution for x. And also we need to determine what value of a should we use. So to observe what kind of substitution to we use, you may look at the two expressions on the right hand side. Here I have a negative 2 coefficient for x, whereas here I got a positive 2 coefficient for x. So this will give you a hint that we should try substitute x with negative x. And we substitute to see whether are we able to transform this inequality into this form. Okay, so let us try. So we have minus x plus 3a less than a plus 2x. So let us modify the left hand side a bit. So we should have modulus minus x minus 3a less than a plus 2x. Why do I do that? Because I want the coefficient for x in the modulus to be positive one. So I try to take out a negative sign, and applying the modulus property, I can take out the negative sign from this big modulus, take it out on its own. So I should have x minus 3a less than a plus 2x. And take note, modulus of negative 1 is just 1. So I have this. And finally, how do we get into this form? It's very clear that you let a p equals to 2. So once we know that we should substitute x with negative x, let a be 2. So our solution to this inequality will be minus x less than negative. Now because my a is 2, so I have negative 4 over 3. And this will simply give me x greater than 4 over 3.